Right. Welcome, ladies and gentlemen, to this presentation. Today, I'm talking about position, displacement, and distance, which is part of our topic we call kinematics. Right. So, kinematics is in two forms. We have what is called horizontal motion, and we also have what we call vertical projectile motion. So, today, I'm just looking at motion in one dimension. Although we also deal with motion in two dimensions, we rarely cover motion in three dimensions or in more dimensions. So let's start with displacement. The first thing that we do in physics is we normally deal with what we call frames of reference. We have we use the x-axis and the y-axis as our frames of reference, right? And when we deal with the kinematics, we usually consider we take a point as a reference point. Like if you look at this one, let's see, if we were to model an object moving in a horizontal along a horizontal axis, for instance, then our reference point would be the origin here. You see where the point 0, it will be our reference point. So when we measure position is a vector quantity. We use the symbol x or y, right? And it's measured in meters, right? Position is, by definition, where an object is. It describes where an object is relative to a reference point. So in this case, our reference point, we call it the origin, which is 0, the 0 point there. Like, you know, the x-axis, this will be 1, 2, 3, 4. So if an object is here, for instance, here, at that point there, if you can see my cursor, it is 1 meter to the right of the reference point. If it is there, it is 2 meters to the right. If it is there, it is a meter to the left. Right. So remember, with vectors, we use plus and minus. Right. I hope that is clear. So, right. So if an object, for instance, moved from point A to point B, we have there's a change in position. And by definition, displacement is a vector quantity which is defined as change in position. So change is always final minus initial. So if it's changing momentum, it's final momentum minus initial momentum. Now in this case, we have change in position, which is displacement by definition. Is given as final position minus the initial position. So in this case, the final position would be 3. Is 3 meters to the right, which is plus 3. The initial position is minus 2. So if you use the formula 3 minus 2, you find that the displacement from A to B is actually 5 meters to the right. This is by calculation using this particular formula. Right? This formula only works, I think it's a lot of tutors, they forget to emphasize this. It only works for straight line motion or one-dimensional motion when dealing with 1D motion. Okay, so in which case we are going to have let's look at this. So we said delta x is equals to 3 minus 2, which is 5 meters to the right. Okay, if you were to look here from A to B, the displacement is 1, 2, 3, 4, 5. So it's easy, right? Bear in mind always that displacement is measured always from start point to end point in a straight line. In a straight line, because displacement measures the shortest distance between the start point and the end point. And the shortest distance, you can only get it if you move in a straight line. Right? I hope you get the logic there. So this is the formula that we use only for one-dimensional motion. Only when we are dealing with one-dimensional motion. Right? And you bear in mind in this case, because in this case, the point of reference for the position is this one, the 0 point. But the reference point for the displacement was A with the starting point. But usually, as I will explain here, usually position, I think I need to emphasize this one. Usually position and displacement are exactly equal. Okay, let me just go to it a bit. Look at this one. This is the origin 0, and then the object is at position given by coordinates from here to here is 2. So x is 2, xy, no, the xy coordinates, and the y here is 3. So it's in position 2, 3 there, right? So the position, if this is O and I call this P, right? The displacement is from the start point, from O to P. The position also is the position is where an object is relative to that the reference point, which is also the same reference point. So you will see that when we deal with especially with the vertical projectile motion, and with most of our motion studies, you will find that the graphs that we are going to draw for position versus time graph, you can interchange the words position and the displacement. It will be, because position and displacement will be the same because the reference point is the same, right? So they are both vectors, both measured in meters, and they are exactly equal from the position of this. If you can find this distance, obviously you will have to find it by Pythagoras. I'll come to that. You will have to find it by Pythagoras, not by this method, right? Okay, we'll talk about that shortly. Okay, now another way, if you don't want to use this formula, is you can do it diagrammatically. Whenever you are adding or subtracting vectors, you are basically adding, you are summing them up. So this is the equivalent to 3 plus 2. So you can just figure it out. Then you're going to draw the position vector, 3 meters. That is the final position, B. Then the initial position, if it is being subtracted and it was negative, so you're actually adding it. Now it's plus 2. So you add 2 more, tip to tail. Remember how you add vectors. You find that the resultant is this one. The resultant must be tail to tail with the first vector that you draw and tip to tip with the last vector you draw. You know the method. So therefore it's 5 meters to the right. Right. If you save time, instead of saying 5 meters to the right, you can just say 5 meters right. Right. This is just another example. If it moves from B, position B to position where it is 1 meter to the right. So your final is 1 and your initial is 3. If that is the case, you start by drawing your final because you want to subtract the initial from there. So you see, it's to the right. Your final is 1 meter to the right, but you are subtracting your initial position, which was positive. Now it's negative. So you are going to have -3 there, and then that is tip to tail there, and then your resultant will be tail to tail with the first one, tip to tip with the last one. You find that the answer is -2 meters. And obviously, because we are dealing with vectors, displacement is a vector, position is a vector. Because we are dealing with vectors, your delta x is 2 meters left, or 2 meters to the left. Right, I hope you get that one. Let's come to this one. Let's say a car moves to the right, and then it moves to the left. You see, it moves to the right. Let's say it moves to the right 2 meters, and then it moves to the left. No, sorry, it moves to the right, and then it moves upwards. at 90 degrees, that will be, if it is to the, okay, let's say it moves, the car moves to, this is to the right. It moves like this to the right, which is 2 meters. And then it moves at 90 degrees. If it was moving to the right, now we can say it's moving upwards. Okay, it's moving east. Yeah, let's use east. It's moving east. And then now it's moving north. Okay, that's possible. So now it's in that position P, which is that one. It has moved 3 meters here. It moved 2 meters there. So the actual distance it has traveled is 2 meters. Let me write 2 meters, that's 2 meters plus the 3 meters. That's the actual distance it has traveled. So distance is described as the length of path traveled. Right. But if you are here now at P, at here, if they ask for the position is measured, the reference point is the starting point also. So you see the position there would be the hypotenuse there, which you can find by Pythagoras. So it will be 2 squared or 2 minus 0 squared plus 3 minus 0 squared, right? All that under the square root sign. You know Pythagoras, everyone knows how to do it. And then that gives you the magnitude of this position vector, right? You also realize that this position vector, like I said a few minutes ago, it is also the displacement. So you get the displacement is measured from the start point to the end point by using Pythagoras and not by using this xf minus xi. I hope that is clear. And then for those who have done complex numbers, if you have done undergraduate mathematics, and for you learners, just get to know that you might go in future into more details. This would be 2i, your x is I, your y is j, this will be 3j. We can also have another dimension, k, and so on. There's multiple dimensions you could have. You know, what do they call it? Yeah, you can go up to n tuples. Yeah, for those who have done complex numbers, vectors and matrices, I think you are all familiar with that. So that is how we are going to deal with it. So don't forget you are going to use Pythagoras. And also, if now this object is at position P, you must be able to describe exactly where it is. So you will need the bearing. So bearing is measured from north, clockwise direction, that you need that angle. But to get that angle, use your right angle triangle, this one. This is the right angle triangle. You drop a vertical there. Oh, it's here already. Okay, this is our, so you're going to have to find, maybe you can find this angle, right? If you find that angle, subtract from 90, therefore you can get the bearing there. So it's easy, you can use your trig ratios. Once you have a 90-degree angle, right, you can use for this angle, definitely, this is opposite, this is adjacent, so you can use tan. And then the displacement here, or the position, delta x, like I said, you find it by Pythagoras. I hope that is clear. And then distance is straightforward. It is the length of path travel. If you travel from A to this position, you measure, you add all those distances. You add all those distances. So distance is never negative, like the vectors. It is never negative. So distance is always positive. You get a positive answer all the time. You just add up all, wherever you walk, add everything up, that is distance. So it is called the length of path traveled. Whereas displacement is measured from start point, can you see A there? Can you see the arrow to show that it's a vector? To point B. So where you ended, that gives you the displacement. If it is a circle, my circle is not very nice. It looks like an apple. You start at point A, you come back to point A, you go like this, and you come back to the same point. Then your displacement is 0, because the distance from start point to end point is 0. Right. When it is 0, you just say 0 m, 0 meters. That's the answer. You don't need really to say left, right, because it's right where it started. Right. I think that is all I want to say. All I can encourage you to do is please, after you have listened to this video, take some exercises on position, displacement, and see if you're able to calculate it. I hope you have enjoyed this one. Thank you. And don't forget to subscribe. Don't forget to press the like button. Subscribe, please. We want to give you as much quality content as possible. Thank you so much.